I am going to discuss about how to implement 3-input NOR gate by using pseudo NMOS logic. So previous video we discussed the implementation of 3-input NAND gate by using pseudo NMOS logic. If you need it, kindly refer the video now. We move on the session. So first I will draw the pseudo NMOS structure. So in this structure it consists of one PMOS transistor, then pull down network. These are the input of pull down network. The gate terminal is connected to ground. PMOS transistor gate terminal is connected to ground. So this is the PMOS transistor. Pull down network consists of NMOS transistor. Now I draw the symbol of 3-input NOR gate. This is the 3-input NOR gate symbol. Here inputs are A, B, C. Output is Y. The Boolean expressions A plus B plus C the whole power. So this is the Boolean expression for 3-input NOR gate. Now I write the truth table. So here inputs are A, B, C. Output is Y. So these 3 input making 8 combinations of input 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1. So then find the output. Here the outputs are A plus B plus C the whole bar. So A value 0, B value 0 and C value 0. Just to add this 3 value, 0 plus 0 plus 0, the output is 0. So complement of 0 is 1. So here Y is 1. Remaining all the cases, the output is 0. Because the NOR gate output is complement of OR gate. So before converting the structure 3-input NOR gate into pseudo NMOS logic, recollect the rules. So dot operator present in the Boolean expression, PMOS transistor connecting parallel, NMOS transistor connecting series. Suppose plus operator present in the Boolean expression, PMOS transistor connecting series, NMOS transistor connecting parallel. So using these rules, now I am going to convert this 3-input NOR gate into pseudo NMOS logic. So in this structure we have only pull down network. So pull down network consists of NMOS transistor. I just ignore this PMOS transistor connection. So as usual, you draw VDD and VSS. Then pull up network PMOS transistor. The gate is connected to ground. So next one, pull down network. So in this Boolean expression, so plus operator present in the Boolean expression, you just consider this rule, NMOS transistor connected parallel. So here we have a 3 input A, B, C. So these 3 transistors are connected in parallel. Then this connect to VSS. Output will get from here. So it's Y. Now I substitute the input value in this circuit. So let me consider this value. A value 0, B1, C1. So A0, B1, C value 1. So in this case, so T2 transistor, this one T2, T3 and T4, this one is T1 transistor. So in this case, T1 transistor is turned on because the gate is connected to ground. So ground equivalent logic value is 0. So this transistor is turned on. Here T2 transistor turn off because gate value is 0. T3 transistor turn on, T4 transistor turn on. So in this case, VDD is connected to ground through the transistor T3 and T4. The corresponding output is 0. So here the output is 0. We will take one more condition. All three input values are set to be 0. So A value is 0, B value is 0, C value 0. So in this case, T1 transistor turn on, T2 turn off, T3 turn off, T4 transistor turn off. So this VDD is connected to Y. The corresponding output is 1. So in this truth table also the corresponding output is 1. So this is the simple way to convert the 3 input NOR gate into pseudo NMOS logic. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make lot of videos. Thanks for watching my channel. Thank you.